Subject name Operating Systems. Second year, fourth semester. Topic Virtual Memory Segmentation. Unit 4. Virtual memory. It is different from physical memory. Virtual memory involves the separation of logical memory as perceived by users from physical memory. This separation allows an extremely larger virtual memory to be provided for programmers when only a smaller physical memory is available. Virtual memory. Virtual memory address space of the process refers to the logical or virtual view of how a process is stored in memory. Say in the virtual memory, there are so many pages are included. The next is a memory map. The another one is a physical memory. Finally the value is stored in the one storage database. So each and every one is communicated with each other. What is segmentation? The memory is divided into variable sized segments and each segment is assigned to a process. This technique is more flexible than paging but requires more overhead to keep track of the allocated segments. Segmentation is a memory management scheme that supports programmer view of memory. Logical address space is a collection of segments. Each segment has a name and its length. The address specifies both the segment name and the offset within the segment. A logical address consists of two tuples, segment number and offset. In the logical address, so many things are involved, that is subroutine, stack, symbol table, main, program and square root. So all the function will be included inside the logical address. Let us see what is segmentation hardware. Although the programmer refers to the objects in the program by a two-dimensional address, the actual physical memory is still a one-dimensional sequence of bytes. Thus, we must define an implementation to map two-dimensional user-defined addresses into one-dimensional physical addresses. Logical address space and physical address space, both we can combine together and we can say main memory. In the CPU, yes, that is segment, D is a displacement, that is offset. So both are assigned and the value will be stored in the segmentation table. Whether the segmentation table values, that is offset value, is available, it will be added the address with the physical memory and store the process inside the physical memory. Otherwise, suppose any error is there, it will be trapping the address error. By using that previous diagram, we can conclude logical address contains two parts, a segment number S and the offset D. The segment number is used to index to the segment table. The offset D of the logical address must be between 0 and the segment limit. Example of segmentation. 5 segments like 0, 1, 2, 3 and 4. That segment table has a separate entry for each segment, giving the beginning address of the segment in physical memory or base address and the length of that segment or the total value, or otherwise we can call it as a limit. Suppose the segment 2 is 400 bytes length and it will be begins at the location 4300. So the reference to byte 53 of segment 2 is mapped into the location 4300 plus 53, which is equivalent to 4353 is a position of that reference byte. So let us see this example of segmentation. So this diagram will help you to find out what is segmentation. So this is a logical address space. Inside the logical address space, subroutine, stack, symbol table, square root and main program. So these are the 5 segments are available inside the logical address space. So this is a segment table. So base address and the limit is given. So address will be started here So this is a 1400 address. Here segment 0 will be started in the 1400 address space, that is base address is 1400, so that limit is 1000. So we need to add 1400 plus 1000, so the total value is 2400. So this is the place of segment 0. So check the next one, segment 1. Segment 1 base address is 6300. Find out where is the 6300 memory space is there. So this is a 6300. So in this 6300 is a base address. So add 400. So 6400 plus 6300 plus 400, 6700. This is a limit. So segment 1 is placed here. Take out the segment 2. So 4300 is the base address. See, so 4300, this is the base address. So added with 400 of limit of segment 2. So we need to place segment 2 on this place. Segment 3 is a base address 3200. So base address is 4300 added with 1100. So 4200. Segment 3 will be placed in between. Finally, segment 4, this one's base address is 4700. See here 4700 is given. This is a base address added with the limit 1000. So in that place segment 4 will be placed. So this is an example for segmentation. Thank you.